Star Wars Calculus Lab, which is not really, like, it's basically like a study hall for them to work on their calculus. That's not true. We had one party.
I came in here twice and there's no party.
That's not true. We had one party. We just eat food a lot in there.
No, it's two parties. You got a birthday party for Fudge.
Not true.
Your baby shower.
We did not have a birthday party for Fudge.
That's not true. There's cupcakes and there's drinks.
That's not true.
I ate them. I came in here that day and had a cupcake.
Food is not, just food does not make a party. We did have a baby shower, and we played baby shower games.
It was out of control.
We did have a baby shower, I will admit to that.
You guys ate poop out of the diet.
That's not true.
So it looked like to me.
First of all, we didn't eat anything out of a diaper. But we played a baby shower game where you melt candy bars in a diaper so it looks like poop, and then you have to guess what candy bar it is. So you have to open it and smell it, and you're like, ooh, I think that's a Snickers.
Candy bar.
I know. We did not eat them. No one ate them.
I'm pretty sure you actually.
Not true. So, what if we looked just on the x-axis from negative pi halves, which would be like right here, to positive pi halves, which would be right here? We would just get this one little bitty section of this graph, right? Does it pass the horizontal line test if I just look at that one little bitty section? How do they pick this one section? Well, there's certain things that they look for. And the thing is that you don't have to really know these things. You just have to know what the restricted domain is. But this is how they choose these. One, it's always increasing or always decreasing on that restricted domain. And we could say that on this little negative pi halves to pi halves, that graph is increasing the whole time. The other restrictions on picking this domain, it covers the entire range, like it goes from the lowest y value to the highest y value. At negative pi halves, it's at negative 1. At positive pi halves, it's up there at 1. So that's another rule that you have to have in order to restrict the domain. And then the third one, probably the one that makes the most sense to us that we've talked about, is it's 1-to-1, which means it passes the horizontal line test. That's what 1-to-1 means. And so although we've already done some stuff with inverse trig functions, we have not talked about that, technically speaking, when you're doing inverse sine, these are the only values that you can use between negative pi halves and pi halves. And so that's a big thing today as we talk about this. And every trig function's inverse has a restricted domain, because otherwise it wouldn't be a function, okay? So let's kind of talk about what does this inverse mean, how are we going to write it, how are we going to say it, and then evaluate some problems with it. We're really getting close to a test again in here. I know you're super excited about that. But we have 4-7 we're going to spend a couple days on, and 4-8, and then maybe next week we're going to have a test. So, yes. Probably we are. I'd love to have Chapter 5 test before spring break, but our 9 weeks ends the week before that anyway. So even if we do have our Chapter 5 test before spring break, it will be the week after the 9 weeks is over. So yeah, we're probably just going to have one more test. I mean, we might squeeze Chapter 5 in, but we'll see. There's a good chance I'm going to have a baby sometime during Chapter 5. So there might be a little extra days in there. Yeah. I did grade those retests yesterday. I haven't put them in the gradebook yet, but I should do that by the end of the day today if you want to see your grade there. So here's kind of the definition. We're not going to write this out again for all 6 trig functions. I'm just going to give you like the big definition for sine, and then we'll do the other ones. But if you have the restricted domain from negative pi halves to pi halves, then we can say that y equals sine of x has an inverse. And the way that we've done it so far is we've used that button on our calculator that says y equals sine to the negative 1 of x. We don't say sine to the negative 1 in math class. We say inverse sine. And the same thing as inverse sine is arc sine. Those mean the exact same thing. Most people write it with the negative 1 because that's how the calculator does it. But just know that I'll use both and the book uses both. Both of those mean the inverse of sine. And it really means the angle, or arc, that's where that comes from, whose sine is x. And so how have we used this in the past? When we're trying to find what the angle is, that's when we use the inverse, like when we're going backwards. So let's kind of write about what the difference between these two functions. Normally with y equals sine of x, right? It's our normal xy, so we think about we're going to plug in the angle here. So we pick like 0 and pi halves, pi fourths, whatever we want to pick. We pick the x, which is the angle, and the output, what we get out of it is the actual value. So we get out the value. Well, remember the definition of inverse means the domain and the range have switched. So if we're talking about the inverse, the value is now becoming the x, and the angle is becoming the y. So just to show you this, that the x and the y are switching, if you see arc sine, or inverse sine, how it's written, the x is now your value. So now you plug in the value, and your answer, your y values, are the angles, and you get out the angle. Also know that this is exactly the same as saying this. So like I guess we could draw an arrow to this, and this arrow also goes to that. Like that means the exact same thing. And so the big thing today, like you're not going to be graphing on your homework today. The big thing today is going to be getting used to seeing this and evaluating it. Your answer is going to be an angle now, whereas in the past our answer has been like square root of 2 over 3, or square root of 2 over 2, or 1, or something like that. So one more little thing here, and I promise we'll get to from. Oh, just kidding. Must be on the next page. Can I go? Yeah, this is our last big writing thing. Then we'll do some problems. So we can say that the inverse sine function is defined as y equals arc sine of x, or if you prefer, you could write that as inverse sine like this. Those mean the same thing. If and only if sine of y equals x. And if you notice, it's just that I've changed the x and the y around. And that goes back to our definition of inverses, which is y in Algebra 2, and in the first semester of this class, we talk about what is an inverse, how do you find an inverse. And also, if you think about the domain and the range switching, normally on sine of x, do you agree that the domain is my angles and the range is from like -1 to 1? Well, for the inverse, it's going to switch. So now my domain is -1 to 1, and my range is my angles. And so the x and the y values have switched in this inverse trig function. The big thing that you have to remember is when you're evaluating these, your answers can only be in this range. There's never going to be an answer of pi for arc sine, because arc sine is only defined between negative pi halves and pi halves. So when it says evaluate, it's not going to remind you of that. You have to remember that your answers have to be between negative pi halves and pi halves. And so that's why I spend so much time talking about it has to be 1 to 1. It has to, because if it doesn't pass that horizontal line test, then it's not a function anymore. So you have to make sure your answers are between this. So these are going to be the kind of questions that you see on your homework today. And I'm going to kind of show you like some brain work, and you're welcome to rewrite this every time if you want, but eventually maybe you won't have to because you'll just know what it's saying. But when it says evaluate arc sine of 0, that's like saying it's giving you the value, and they want to know what angle equals that. So another way to say this is saying sine of what this is saying. So remember that this is the value, not the angle. Maybe I shouldn't have started with 0. So it's like saying, what angle has a sine of 0? And that's where you got to know these values. What angle has a sine of 0?
Should I be thinking like a graph or
Well, I think unit circle, but you could think graph if you want, I guess. I think about my unit circle or my triangles is sine the x or is sine the y.
negative pi halves, 3 pi halves, right?
Yes, negative pi halves would be, like, this would be negative pi halves of 2 pi halves. Because we're kind of talking about this area right here if we're thinking about the unit circle. Remember, sine is the y coordinate, right? So where's the y coordinate equal to 0? On the x-axis, right? And the only place on the x-axis that passes from negative pi halves to pi halves is 0 itself. And so this is where if you gave me an answer of pi, it would be wrong. Is sine 0 at pi? It is.
Okay.
But it doesn't fit within our restricted domain because it doesn't pass the horizontal line test. So you have to say the only answer here is 0.
It couldn't be 2 pi?
Because 2 pi is not in this range either. You see what I'm saying? Like, it's very specific. If you think about the graph of sine, if you want to think about it that way, negative pi halves to pi halves like we just drew,
Okay.
like, it would just be this one little section of that graph where this comes down. So it's like that's it. Like, that's the only section of the graph that we're looking at, so you can never give me an angle outside of that. And so when we have a test, this is what you have to remember so that you don't give me pi or 2 pi as your answer. Let's try that one.
So arc sine and inverse sine are the same thing?
Exactly the same thing. And so again, what you want to start thinking about when you see arc sine or inverse sine is you're trying to figure out what angle has this value. So like in your head, you're asking yourself, what angle has a sine of negative square root of 2 over 2? Or if you want to write that out, you could say the sine of what equals negative square root of 2 over 2 is kind of what you're should be thinking to yourself when you do this. So again, when we have the test, there's definitely going to be a no calculator section, and this stuff would show up on the no calculator section of knowing your values of your unit circle or your triangles. Do you agree when we see square root of 2 over 2, we're definitely thinking of the pi force or the multiples of pi force?
So all these problems are the same thing.
If it's sine, it has to be between this every time.
Okay.
Okay, so again, I heard someone say 7 pi force, which I agree. 7 pi force, which is right there, does have a sine of negative square root of 2 over 2. My question is, does 7 pi force fit between negative pi halves and pi halves? So could I write 7 pi force in a different way so that it fits between that range? You're right, it's this quadrant to this quadrant, but we're in terms of like zeros in between that. You see what I'm saying? Like, think about the first graph I gave you. Let's go back to that for a second. Like, if you think about it like this, is 7 pi force in between there? Right? Like, 7 pi force is way over here. It's not in that little section of the graph. And so you have to think about that quadrant 4 is going to be your negative angle. So instead of 7 pi force, this would be negative pi force. And instead of, what would that be, 11 pi 6, what would it be in terms of negative pi 6? And so you are going to give negative angles, which we haven't really done a whole lot of before. So I think the answer here has to be negative pi force. And that's the part you have to be careful of, because it's really easy to say 7 pi force. But there's only going to be one angle that fits in that little range. What about this one? This one says inverse sine of 2.5. So that's like saying sine of what angle equals 2.5. What if this was on a no calculator part of the test?
That's probably one.
What's the, let's look up here for a minute and look at my domain and range and see if maybe we can remind ourselves what the answer to this is going to be without. Can sine ever be 2.5? No, it's going to only be between -1 and 1. If you try this on your calculator, it's going to say error or domain. So it's kind of a big hint, which means on a test, I definitely would put this on a no calculator section because I want you to realize that sine cannot be bigger than 1, cannot be smaller than -1, which means that it's undefined, no solution, however you want to say that. I want to look at the graph of this just to kind of show you where it comes from again, of why we're restricted between negative pi halves and pi halves. And then for the other ones, I'm just going to show you the graph. Like, you're not going to have to graph these by hand, but I feel like if you understand where the graph comes from, this part makes a little bit more sense. Okay? So let's look at this one graph of sine, arc sine, and then we'll be done. Well, not done, just kidding. That was a joke. Yeah, it's pride time. I don't know. Remember that we're switching places here, so if we're making an XY chart, remember that Y is actually going to be our angle, and X is going to be our value that we get out of it. If you wanted to, could we make an XY chart for just sine of X and then switch the ordered pairs? We did that back when we were first graphing inverses, if it was hard to pick the XY chart for this. But we could pick angles here if you wanted. Like, we could pick 0. And actually, let's think about what my, I'm restricted, I already know, between negative pi halves and pi halves, so maybe I should pick those values. Start with negative pi halves, maybe pick negative pi fourths, and then 0, and then pi fourths, and then pi halves. But notice these are my y values, not my x values, because that's what happens when you do the inverse. And so this is going to be, what is the value when you take the sine of this angle? Do you agree with me on that? So I'm kind of working backwards on this. So let's start with maybe at negative pi halves. What is the sine of negative pi halves? -1. What about negative pi fourths, which is the same as 7 pi fourths? What is the sine of that? Negative square root of 2 over 2. Not so pretty. I think I did, I think it's like 0.7. Like negative 0.7071, I think, if I remember correctly. I don't know why I need 4 decimals, but. What about 0? What's the sign of 0? And what's going to happen for positive pi fourths and positive pi halves? Yeah, the same, just positive. Yeah. I'll check my decimals here. So this one's going to be positive 0.7071 and positive 1. So I just want to show you this. Notice when you graph this, the y values are now my angles. So I need to go up 2 pi halves. So I'm just going to make this one pi fourths and this one pi halves. And down to negative pi fourths and negative pi halves. And my x values are my numbers, which are from, I'm just going to kind of go right here, negative 1 to 1. So again, notice with an inverse, the x and the y have switched places. So my x and y axis have switched. And if I graph this, at -1, it's at negative pi halves. X negative 0.7071. That's not quite 3/4 of the way over there, but somewhere between 1/2 and 3/4. I'm just going to kind of go about right here. It's at negative pi-4. At 0, it's at 0. At 0.7071 positive, it's at pi-4, and then it's at 1. It stops there. It never gets any bigger than that, which is why all of your angles have to be between that little section. It never goes outside negative 1 to 1, and it is still just like a smooth little curve. And if you remember anything about inverses, they're reflective of each other. If we take all these points and switch them around, then we now have the sine curve. And so this is our inverse sine function. You're not going to have to graph that, which is why the other ones I'm just going to kind of show you a picture. It's in your book. You don't even have to copy it down. But I just want to show you that why it's so restricted. That's the only way that it will be a one-to-one function. So let me show you cosine and tangent. I'm not going to show you the reciprocal ones, secant, cosecant, and cotangent. They have lovely graphs also, but I'm just going to give you the intervals for them. Okay? So I do recommend that you write this, but you don't necessarily have to just show the picture here. But for cosine of x to have an inverse, again, it has to be either increasing or decreasing the whole time. It has to be 1 to 1. And the place that happens is from 0 to pi. So it has a restricted, your answers only can be between 0 and pi. I forgot what page this is on the book if you want to write the picture down. There's lovely pictures in your books that I copied. You don't have to copy the picture here, but that's what it looks like. Again, notice that the x-axis goes from negative 1 to 1. The y-axis only goes from 0 to pi, because otherwise it would not pass the horizontal line test. Mm-hmm. So when you evaluate inverse cosine, I'm going to see if I wrote this here. Oh, yeah. When you evaluate inverse cosine, they can write that as arc cosine or cosine negative 1. Your answers are always going to be only in between 0 and pi. And again, that's just one more thing to go on that list of things you have to remember. Page 416, if you want a page number for this lovely graph here. And again, we could go through the same thing of talking about drawing the graph and everything, but I feel like you don't have to graph these, you just need to know how to evaluate them. And the good news is the reciprocal functions have the same restriction, so that's why I don't really talk about them. The reciprocal of cosine, which is what? Secant? Inverse secant has the same restriction, so if you know inverse cosine's restrictions, then you know inverse secant. So that's why we're not going to worry about it. Quadrant 1 and quadrant 2, yep, and they're all positive, 0 to pi. So you can give me an answer like pi halves, but you would never give me an answer of 3 pi halves. You could get 3 pi fourths. Yep. For tangent of x, where does it meet those rules? Guess what? It's the same as sine. So that's the nice thing. And if you think about what tangent normally looks like, it looks like we've kind of turned that little S curve on its side. But basically, we've just taken one set of asymptotes. Because if you go outside of that one set, then it's not 1 to 1 anymore. But tangent of x is increasing and 1 to 1 from the interval negative pi halves to pi halves. So when you are evaluating inverse tangent or arctangent, all of your answers will be between negative pi halves and pi halves. And again, you don't really have to draw that picture. I don't think there's need to. It's on page 417 if you really want to get a better look at it, but I just wanted to show you what it looks like. think I have a couple more examples I want us to do using these. And I think there's some on your homework today. I think we'll get to those too, where you just get to use your calculator, which we've done before. If you're solving for the angle, you can just use your calculator. And the good news is your calculator gives you the answer, I do believe, in the right. Yeah. And so I think maybe on the next page I've kind of summarized this for you of the domain and range of each one, so that you have kind of something to go back and look at for these three. Can I go? All right, so let's look at this really quick. I'm just going to kind of summarize this. The restricted answers that you're going to give on these, so the domain of each one of these versus the range of each one of these. And this is kind of your summary of all the stuff that we've just done. Remember that we've switched, so the domain is actually the output now. So the domain on sine and cosine are the biggest and smallest that sine can ever be, which is -1 to 1. The domain on tangent now, am I writing this wrong? No, I'm writing it right. Is all real numbers. And think about, normally the range on tangent is all real numbers because it goes up and down. If you look back at that picture, it's now going side to side. So there is no restriction on what tangent can be in the domain. But the range is now the output, the angles. And so this is the part that you have to know to give your answers. Sine and tangent are the same. It's negative pi halves to pi halves. And then for arc cosine, your answers have to be between 0 and pi. And so you kind of have to remember that arcsine and arctangent go together, and that's negative pi halves to pi halves. Your answers will only be in that little area. But then arc cosine is different. It's 0 to pi. And so I just want to practice a couple of these as well. Maybe I just have one on here. Yeah, because this is like my thought bubble here of what you're thinking about when you do this. And again, it's kind of up to you on how much work you need to write out when you do these. But anytime I'm evaluating an inverse trig function, I always think about what's my interval got to be in, so make sure my answer's in the right interval. And then remember that you're asking yourself, what angle has that value? So your answer is always going to be an angle when you're doing inverse trig functions. And so what is the interval for arctangent? Well, I better make sure my answer is between negative pi halves and pi halves. And then the next question is I have to know those triangles or the unit circle. I got to know something that in that interval, where does tangent equal the square root of 3? Or maybe you can think about it as the square root of 3 over 1. So I'm thinking about my circle here. If tangent is positive square root of 3, and I know I have to be here or here, which quadrant am I in? Am I up here or am I down here? Definitely in quadrant 1. You agree with that? And do you agree it's either going to be pi 6 or pi thirds? Because it's the only one that has a square root of 3 in it, and it's just like we've been doing before. You just have to figure out which one it is. Tangent is opposite over adjacent, so which one's going to have an opposite side of the square root of 3? I think it should be up here at pi thirds. If you're a unit circle person, then you take those order pairs and you put them over each other. But this is where I'm not a unit circle person. I really like the triangles. Questions on how I'm getting that? If you don't have work to go with that, that's okay. You can figure the answer out. I mean, it's a lot of brain work, not a lot of writing down work. Let's see if we can try it anyway. Maybe I'll let you do this. So again, what you should be thinking about, I'm not going to tell you the answer right away. I want you to think about it. But what is my interval? Where does my answer have to be? So you want to make sure your answer is between the range that I gave you. And then, where does cosine equal that value? What angle I tend to write it like this. Cosine of what equals negative 1/2 is what that's saying. And what's the interval for arc cosine? 0 to pi. So you want to make sure your answer is in that interval, which means you can only go from here to here. So you're just in quadrant 1 and quadrant 2. Again, you should be able to eliminate it. If cosine is negative, am I going to be in quadrant 1 or quadrant 2? Quadrant 2. And if it's negative 1/2, again, do you agree that I'm either going to be up here or right here? And it's just knowing which one it is, whether you know the ordered pairs, cosine is x, sine is y, or you draw the triangle. It's this one, right? Which is 2 pi thirds. And maybe you just have 2 pi thirds on your paper because you have a unit circle off to the side that you're looking at. And I'm okay with that. It's just you got to know how to do this when it comes time for a test. How do you feel about that? It's not terrible, right? I don't know. Let's move to here. That was my last slide. Oh, I just want to check with you on the calculator stuff if we're okay with that. I feel like we've done this already, but maybe not. But we're just going to use that button on our calculator. Make sure you read the directions. Like some of your homework says give your answer in degrees, and some of your homework says give your answer in radians. So you want to make sure you're in the right mode. So let's do this one in degrees and this one in radians just to practice. And we have that button, inverse cosine, and you're just going to type it in exactly as it says. So I'm going to change that on my calculator. It's going to look like this, of negative 0.7. And you want to make sure you're in degree mode. If it says degrees. And it tells you what to round to in your homework. Let's just go 2 decimal places on this one. I got 134.43 degrees. Just typing that in my calculator. And I think there's like 8 on your homework that you just get to type in your calculator. But it is an important thing. A lot of people miss those on the last test, the ones that you're using your calculator on. The biggest thing is make sure you change to the right mode. Anyone need help or having issues with their calculator on this? We can do the same thing for inverse sine, only if the direction said to use radians, then I'm going to change my mode to radians. And I'm going to hit that inverse sine button. And that's really saying what angle has a sine of 0.31, which is not my unit circle. And it's, remember, radians are going to be not so pretty numbers here. But if I just go 2 decimals, I think you get 0.32. So today isn't a terrible day, but it's a kind of a big day of making sure that you know the intervals and you're able to evaluate these. It's a good review of your unit circle and your triangles. Tomorrow, we're going to take this idea and apply it to some harder things. So it's really important that you get tonight's homework done. Questions about that? About that, this is your homework. This is 4-7-day 1. I did check the assignment sheet. It is the same. I don't know what happened on that one when I just changed numbers. But 1 through 20 all, 59 and 60. And yes, 1 through 20 all, but they're all just like evaluate. There's no graphing. It's just evaluate over the interval or evaluate using the calculator. Okay? If you have other questions about the homework quizzes I passed out, I'd be happy to answer them. Or if you want to know what you got on your retest, I'd be happy to tell you that as well.